So, from the previous section, you could see that inspiratory muscle weakness is a key contributor of exercise intolerance. Let's take a look deeply on the mechanisms responsible for reduced functional capacity in heart failure with preserved ejection fraction patients. The maladaptations of the right, left heart, as well as the vascular and skeletal muscle, make the abnormality in inspiratory muscle, including respiratory muscle atrophy, veins in muscle fiber ties, muscle metabolic reflex, reduced oxidative capacity, ventilation inefficiency, and physical deconditioning. And all of that contributes to a reduction in peak oxygen consumption. Let's further explore the status of inspiratory muscle weakness in heart failure with preserved ejection fraction. The prevalence of inspiratory muscle weakness in heart failure is 40 to 50%, and this figure in heart failure with preserved ejection fraction is 30 to 40%. Inspiratory muscle weakness is defined as maximal inspiratory pressure, or MIP, less than 70% of predicted value. MIP is a measurement used to assess the strength and function of the inspiratory muscles, particularly the diaphragm. To assess MIP, patients will be instructed to inhale forcefully at residual volume to against an occluded airway of a digital device like this picture, and the MIP will be shown in a number or presented as a graph. In clinical practice, inspiratory muscle weakness is considered as a poor prognostic factor in heart failure. This figure represented the survival rate of heart failure patients with inspiratory muscle weakness by the red line, and those without inspiratory muscle weakness by the blue line. You could see that patients with inspiratory muscle weakness has significantly lower survival rate than those without inspiratory muscle weakness in both heart failure with reduced ejection fraction and preserved ejection fraction. So, what is the solution for inspiratory muscle weakness? An effective way to strengthen inspiratory muscle, inspiratory muscle is in patients with heart failure with preserved ejection fraction is respiratory muscle training. In this method, inspiratory muscle training with resistance training is of great concern because inspiratory muscle inspiration is generally an active progress of diaphragm activities, and it plays a vital role in oxygen uptake efficiency. In addition, the resistance training is user-friendly and more cost-effective than other devices. While the patients train with the inspiratory muscle, the inspiratory muscle training device will provide a stable resistance while inhalation, and patients need to inhale strong enough to get over that threshold. So, how inspiratory muscle training could improve functional capacity? Inspiratory muscle training directly strengthens the respiratory muscles, including diaphragm and intercostal muscle. By that way, inspiratory muscle training improves the pulmonary function, which is one of the most important factors to increase peak oxygen consumption, as I told you in previous section. And it means that functional capacity is improved. In order to gain expected outcome, the inspiratory muscle training program will be set based on three components: intensity, frequency, and duration. The intensity depends on the percentage of maximal inspiratory pressure and divided to high intensity, moderate intensity, and low intensity. An appropriate intensity is very important to optimize the outcome. For example, patients with heart failure with preserved ejection fraction have higher functional capacity compared to heart failure with reduced ejection fraction. So they need to train at higher intensity. There is some previous study of inspiratory muscle training in heart failure with preserved ejection fraction. Till now, only two trials were performed to evaluate the efficacy of inspiratory muscle training in patients with heart failure with preserved ejection fraction. But both studies used low to moderate intensity of IMT. In addition, they used unblinded trial and small sample size and lack of report of the compliance to home-based IMT program. And an interesting finding is no previous studies evaluate effects of inspiratory muscle training in patients with heart failure with mildly reduced ejection fraction. So the gap of knowledge is that there have been no studies conducted to evaluate the effects and safety of high-intensity IMT on patients with heart failure with mildly reduced and preserved ejection fraction.